Can you recover diamonds using normal methods like sluicing and panning? Yes, but are there better ways than these to recover diamonds from alluvial gravels? Yes, there are, and we're going to look into that today in this video. My name is Chris Ralph, the professional prospector, and today we're talking about how to recover diamonds from alluvial gravels. Now first, diamonds come from gravels. They're an important part of world production. It's not insignificant. So it's worth learning about how to recover diamonds from gravels. Alluvial diamonds in gravels are widespread across the United States. They occur in California, in Colorado, Wyoming, and many areas of the Midwest. They are found in all of these areas in sparse, low concentrations, but they are there. During the California Gold Rush, hundreds of diamonds were recovered by the Gold Rush miners from the gravels that they were working for gold. Diamonds that are occasionally found in the gravels of the Midwest have been brought down by glaciers from Canada. They can also be found in gravels in Canada and in Australia, but there are millions of miners working in developing nations that recover many hundreds, many thousands of carats of diamonds every year. Most of these artisanal miners are working in developing nations where they eke out a living prospecting for diamonds. The places where diamonds are being mined by small-scale artisanal miners include South America, India, Indonesia, but especially in many places in Africa. The millions of artisanal miners working on a small scale actually in total produce quite a bit of the world's diamonds. It's estimated that about 15 to 20% of the world's total diamond production comes from these small-scale miners. Larger-scale commercial gravel mining also is important in production and produces about another 10% of the total world production. Diamonds are found in gravels because they don't weather, they don't break down, and they don't decompose. Diamond-bearing kimberlite and lamprey volcanic rocks break down, release the diamonds, and the diamonds do not themselves decompose. They get washed into gravels and drainages in various areas. Areas near the kimberlite volcanics or the lamprey dikes that have diamonds in them are good places to search for alluvial diamonds. However, because they last so long and continue to travel in waterways, diamonds can be found transported a long ways. Sometimes gold and diamonds are found in the same types of gravels, even though they come from different types of deposits. Because they both endure and don't decompose, they can be concentrated in the same types of drainages. Let me show you some pictures of how alluvial diamonds do not show any signs of wear. Here's some alluvial diamonds recovered in South America. And you can see it shows no sign of wear at all. All the pointed corners are pointed and sharp. All the growth faces are sharp. Everything is sharp about these stones, just like they went into a stream yesterday. And yet these stones have been in the ground for millennia, millions of years. They show no wear. And that's why diamonds are found in alluvial gravels, because they can survive basically forever. Many of the artisanal miners end up doing illegal forms of mining, working under difficult conditions and remote locations. The artisanal miners excavate small pits to extract the gravels. The miners often dig down through 10 to up to even 100 feet of overburden to get to the diamond-bearing gravel underneath. Pickaxes and shovels are used to move the diamond-bearing gravels into man-made ponds where the gravels are screened with sieves. Homemade sluice boxes are also often used to process the gravels, and the concentrates are processed for gold, diamonds, and other valuable minerals. Diamonds are searched for by sieving, and they're selected from the sieves by visual recognition. Only a small amount of gravels can be sieved each time, and so the processing method to find diamonds this way is very slow and labor intensive. Sometimes these small miners do serious environmental damage, and sometimes there are political problems and other dangers when outlaw factions use them to buy weapons. Diggers face exploitation, human rights problems and abuses, extreme poverty, and other issues. The miners don't make much. In fact, they make a very meager living, keeping their families fed. Often they're motivated by the hope of a big find. Yet even when diamonds are found, the miners often receive only a tiny fraction of their real value. The miners are often poorly educated on the gem value of the individual diamonds that they've found, and so rely mostly on just the carat weight as being the definition of what the diamonds are worth. Let's take a look at some pictures of the artisanal gold mining operations.
Almost always, the diamond-bearing gravels are underneath a certain layer of overburden. This overburden can be a few feet to tens of feet to even deeper. And because the artisanal miners don't have bulldozers and front-end loaders, they're digging out these pits by hand. This photo shows better the difference between the overburden, sand, and the diamond-bearing layer below. You can see the miner is standing in front of the diamond-bearing layer, which is a little coarser, and then the overburden, which can be sand or clay, is on top. And the diamond-bearing layer can either be dug with pick and shovel or washed away with pressurized water from pumps, as shown in this illustration. The gravels are then washed or pumped into a sluice box system where it's processed, and in this sluice would be contained any gold and the diamonds that are in the gravels. The muddy water is usually not well contained, and this adds in part to the pollution problem from these operations. We'll talk about it more in a minute, but diamonds are actually washed through sluice box systems like this quite easily and out into the tailings. Once the gravel concentrates have been recovered out of the sluice box, they have to be sieved and sorted to recover the diamonds out of the concentrates. Shaking the gravels through the sieve allows the small sand-sized particles to drop out the bottom of the sieve and just take the size particles that are big enough that they could be a diamond worth recovering. Once all the materials in the sieve have been thoroughly shaken and stratified, it's flipped over, and then from the bottom, in the center, are the heaviest materials. You can see in this circle that these guys are looking at, there's a dark circle of some iron minerals and other heavy minerals, and they're looking through there to find some diamonds. This is the process that's necessary to recover the diamonds by this method. It's a very cheap method, but it's very labor intensive and takes a long time, and it's just not that efficient. It does miss diamonds.
On the other hand, the larger scale commercial gravel mining operations that work for diamonds use heavy equipment and gravel mining techniques borrowed from the gold mining industry. Gravel deposits are removed by excavator and formed into a slurry using hydraulic techniques, and the slurry is then pumped into a sluice box or jig to extract the gold and the diamonds that are present in the gravels. The commercial jig and sluice box systems of the commercial miners are much better designed than those used by the artisanal small-scale miners. Heavy minerals, including diamonds, are recovered from the concentrates, and with the smallest fraction being processed for gold and the rest of the larger minerals being screened and sieved to sort out the diamonds. Let's take a look at some commercial diamond mining operations.
So the commercial operators have heavy equipment, and they're able to work much larger openings and larger pits to process the gravel. They also have much larger facilities and are able to handle a lot of gravel with a minimum of personnel. And they have much better recovery systems, often using both jigs and sluice box systems to recover the gold and diamonds that are present in any of the gravels they're working.
There are problems with recovering diamonds by gravity methods like sluicing or sieving because they're just not that efficient. Some of the diamonds, of course, the majority are recovered by this type of system, but many are actually lost because the diamonds are not as heavy as gold and some other gemstones. Even with these problems, as I mentioned, they're not that great, but even with these problems, the small-scale artisanal miners use these methods because they're traditional. They know that they work, they know that they can find at least the majority of the diamonds with this, and of course what they lose, they don't know what they lose. In other words, if you lose something, you don't know that you lose it, so there's not a problem. It's traditional, they know it works, they've been using it for centuries, and so that's why they use it, even though, like I say, it's just not that good. But they are the old and accepted ways of doing it. Let's take a look at some pictures of the process for sluice boxes and sieving for recovering diamonds.
So here is a view of what sits on the sieve. You know, the holes have allowed the really small sand type stuff to go through. But you look at this and, hey, almost all those white particles in there, the white pieces, are all quartz. There's also some clear white pieces that are bits of topaz, that teeny tiny bits of topaz have no great value. There's even a few tiny sapphires that might have some value, some rutile and jasper and things like that. And yeah, there's a couple of diamonds in there too, and it's shown in there. But you can see by looking at this how hard it would be to sort through this all visually. All these little bits are wet, and it's hard to see their surface very well. And so it's easy to lose diamonds using this kind of method. Some are recovered, maybe even more than half, but a lot are lost.
Now, large commercial hard rock miners, that work mining solid hard rock, not gravels, they don't even use gravity or any other technique that we're going to talk about here. They use high-tech X-ray technology to sort through the diamonds and sort them out from all the other rock that they mine. The XRT technology uses X-rays to irradiate the mineral particles on a belt, and then the X-ray cameras to measure the atomic density of each particle. The density data is processed with a computer to obtain a density data for each particle that goes through on the belt. When a diamond is identified, a small blast of air knocks the diamond off the belt into a container. But small operators can't afford that kind of technology because it costs hundreds of millions of dollars to set it up. Instead, as I said, the small-scale miners, both the commercial and the individual artisanal type operators, use sluice boxes and screens, even though they're just not that good for this type of thing, but they use them anyway because it's traditional and that's how it's always been done. Let me explain to you density and how that works, and how these gravity methods work, and why diamonds just aren't that good for recovery by density or gravity type methods. So let's talk about gravity methods of recovering diamonds and other things. Whether you're looking at a sluice box or jigs or a gold pan or even the sieving shaking method that they use, it's still a matter of sorting things by density. And the more difference you have in density between water that you're using to sort this and the item that you're looking for, the better off you are. So look here, you've got platinum and gold are at 19, gold 19, and platinum 24, water is 1, all right? So the density of water is about 1. And so you have these lots denser than water. So it's easy to have a situation where you have a stream of water, like in a sluice box, and there's a piece of gold here. The stream of water goes by, the gold doesn't move, and the sand and quartz and other minerals just keep on going right out the box. Platinum, of course, platinum's 10% even denser than gold. So platinum, no problem. Iron metal, I just threw that in there because a lot of junk, there isn't very much natural iron metal, meteorites and things, but then you have things like hematite and magnetite. Those are the main ingredients of black sand. And of course, if you've ever run a sluice box or a dredge or other type of water-based gravity recover device, you'll know that you catch black sands and that sort of thing, and there's certainly bigger pieces of black sand. But then these are still 5 times more dense than water. But you start going down the scale, and just for comparison, the stuff you want to get out of the box, the quartz and the feldspar and that kind of stuff that you want to just blow on through your sluice or out your pan or out your jig. Quartz is 2.65, feldspar 2.56. So a little more than 2.5 is already the stuff you're trying to get rid of. So zircon, the density around 4.6, a little less than black sands. But I do recover fine zircon sometimes in some of my gravels, depending on where you are. Ruby and sapphire, 4. Spinel, 3.6. Topaz also. Diamonds down to 3.5. And You know, the difference, quartz is 2.6, 2.7, diamond 3.5. There's not that much difference between the two. And so when you get a flow of water that you're going to wash out quartz, you're going to wash out some diamond too, because it's just not that different from the quartz. When you put gold in there, the gold is so heavy and dense that it takes a lot of flow of water to get the gold to move. But diamonds, yeah, not so much. And, you know, diamonds are a lot of times kind of roundy shapes. You know, they're kind of rounded shape type things. And so you get water, you know, going through a sluice box, and the diamond just rolls right on out with the quartz and the feldspar, because it doesn't weigh that much more than the quartz or the feldspar. And that's why I say that while there's lots of different ways to recover diamonds, the gravity methods like sluice boxes and the sieves and the screens and the pans and, you know, all that kind of stuff that all works on this method, that it's a lot different than the item you're trying to recover is a lot different than quartz or feldspar. It works if the item is a lot different than quartz and feldspar. But if you have diamond at 3.5, it's not that much different. So that's why I tell you over and over in this video that these methods are really not that great for recovering diamonds. Now, if you're going to, be mining for gold and you just happen to recover some diamonds on the side, you might say, well, you know, I'm here for the gold, and if I happen to catch a few diamonds, hey, that's good. And there are plenty of operators that are kind of in that ballpark. If you're working in California, you ought to keep, if you're in areas, say, you know, Butte County and some other areas that produced, in certain parts of Amador County, that produced a lot of diamonds, yeah, you ought to keep your eyes open in case your sluice box catches any diamonds. But for primarily diamond mining, it's just not the best. It was a great discovery more than a century ago when it was discovered that diamonds would stick to grease, to a layer of grease on a surface. Grease tables work great to catch diamonds because diamonds repel water and their surfaces won't get wet. Scientists call this property being hydrophobic, meaning the particle of diamond doesn't like water. And this is a property that's unique to diamonds. They're very strongly hydrophobic. They just won't wet. Diamonds are also oleophilic, meaning they like grease and will stick to a greased surface. Other minerals like quartz or feldspar, mica, will easily wet and will flow off of a greased surface. They won't stick to it. And long ago, they discovered that this method of sticking diamonds in a surface coated with grease is a great way to recover diamonds. Grease capture is typically done with sluice box or jig type concentrates. And the concentrates must be sieved and screened to different sizes and treated each size separately. Using the correct type of grease is also critical. It must be solid but not too hard. And it must not be too liquidy either. It has to be kind of in between. Prospectors who employ this method often use Vaseline or something similar to that, a firm type of grease that can be put on a plate to catch the diamonds. Temperature also makes a big difference, as grease will become more and more liquid and less firm at higher temperatures. Grease does a good job even on small diamonds. After the sluice box concentrates are processed, the grease surface can be scraped and the Vaseline or other type of grease can be dissolved with a solvent. The materials recovered from this grease are screened and processed to get both the fine gold particles, and the coarse grains are then inspected for the presence of diamonds. Gold is also hydrophilic and will stick to this, and it actually can increase your recovery of gold if you're working a deposit that has both gold and diamonds in it. The manual grease table is nothing more than a wide, short aluminum sluice with handles for shaking side to side underwater. They can be freestanding or powered by a motor or even incorporated into a sluice box. They can be used in conjunction with gold recovery from the same gravel, and like I say, can even help with gold recovery, especially of the finer particles of gold. There is no doubt that grease tables do increase diamond recovery rates. I also get asked sometimes if metal detectors can see diamonds. And I'm sorry, the answer is no. A diamond is not a metal, and so a metal detector generally won't see a diamond. Now, folks new to diamond prospecting will sometimes ask, well, how do I know what the diamonds look like? How will I be able to recognize a natural diamond if I find one? And that is something that's very good to know. If you'd like to know more about how to recognize a real diamond, take a look at this video I did on the subject. I did a whole video on how you can look at things and recognize the difference between real diamonds and other minerals that may sort of look like a diamond. Because diamonds are so valuable, it's worth knowing what they look like, and that's why I did a whole video on it. Click on the link above and take a look. Gold and diamonds are frequently found in the same gravels together, and most of my videos are about gold prospecting. If you are interested in finding your own gold for yourself, I wrote a whole book about that called Fistful of Gold, and I'm going to tell you a little bit more about my book right now. So let me tell you a little bit more about my book. It's called Fistful of Gold, and I wrote it because I want you to be able to go out and find for yourself Fistful of Gold. And you can see that it's an encyclopedia with all kinds of information, pictures, and that sort of thing. It's not in color, but color would have cost me a lot more to have printed, and so the book would have cost a lot more. It's for sale on Amazon, and you can pick it up. I'll put a link in the description below. I also serve as the editor for a prospecting magazine. It's ICMJ's Prospecting and Mining Journal. And honestly, you should check that out. We got stories and information, legal stuff, everything you know to increase your skills as a prospector. I write articles in this every month, and a lot of other very experienced prospectors contribute to the magazine as well. So check the magazine out. Also, I have a website, and the website is at NevadaOutbackGems.com. I'll put a link for it in the description below, but there's gobs of information there that you will find useful in your prospecting efforts. Finally, I want to say that I really appreciate your comments and thoughts, and even positive criticism. Don't come on there and just toss out insults, because I'll just delete your comments. But if you've got helpful things to say and questions to ask, do write and put those in the comments, because I answer my comments to people, and you'll hear from me in responding to you. So if you've enjoyed this video and you like what you see and you're interested in finding out more, well, then sign up, subscribe, and hit the notification bell so they'll let you know when I post new videos. And like it and share it if, again, you see stuff that you really are excited about. And I'll be coming out with lots more new videos, and so we'll see you again real soon.